Hey everyone, welcome to CSAF. My name is Jessica and I'm here to represent Swift, and we are going to be talking about RF-controlled USB cables today. Before we start, a little note that this was inspired by Luca Bongiorni on his USB Samurai project, so kudos to him for creating such a cool project. So our objective is to create an RF-controlled malicious USB cable. So this could be any cable, right? It's like a random charging cable that you find. And the objective and the idea is that you would plug that into your device, and then an attacker lurking around somewhere could inject malicious keystrokes. So before we get into that, let's talk a bit more about wireless dongles. So when you're using a wireless keyboard or mouse, the way that works is that the peripheral would send the input from like your user input to the receiver. So a little like Logitech RF receiver, it's going to send it to that as radio packets or RF packets. Once the dongle receives that packet, it injects it to the computer as HID packets or human interface device packets. This is very important because there's really no way to distinguish whether or not, a packet was sent maliciously from a different source, like for example, from the attacker, or if it was sent from your wireless device, like this mouse over here. So that is, it's really difficult to detect on the software level. So we're going to be exploiting this using a couple methods, including social engineering. And then on the software end, we're going to be using the Unifying and the Logitech repos or projects. So some hardware requirements. First of all, we require a USB cable. So what I am going to be using is just a normal lightning charging cable, something really unsuspecting. We'll also need an RF receiver or radio frequency receiver. So that's going to be like a Logitech dongle that you plug into your computer, and then a RF dongle. So that's going to be the sender of our packets. But yeah, and then for the software end, we're going to be using the Unifier and Logitech projects on GitHub. We're also going to need firmware for the USB receiver and the RF dongle, so that allows them to be flashed with the correct firmware for them to communicate with each other. And then we'll also be using PuTTY or any other serial console in order to communicate with our RF sender. And then finally, some sort of Linux VM or isolated environment for us to run Unifying to be able to flash our RF receiver. So the project is going to look like this. First, we're going to attempt a test run, make sure all of our devices, so the receiver and the sender, are working properly, and that they're flashed properly and they can pair. Then we're going to build a cable, and then we're going to go into some payload development, and then we'll deploy the payloads. So for the test run, we're going to need first our receiver dongle. So for this project, I picked the Logitech Unifying receiver. And then we'll also be needing the sender dongle. So I picked the NRF, whatever big number dongle by Maker Diary. And then finally, we're going to have to pair the devices using Logitech and Unifying. So first, our Logitech Unifying receiver. So with this plugged into our computer, we open our VM or isolated Linux environment. I was using VMware, so I had to go edit the .vmx file to allow HID devices to show up in the removable devices list. So then I can also, unplug or disconnect and reconnect the devices through this interface instead of having to physically remove it. So it's pretty convenient as well. And if it's not showing up, you just want to make sure, double check your VM settings, make sure both show all USB input devices and share Bluetooth devices. Just make sure those are checked, and then maybe restart VMware if that's still not working. Next, we want to install Unifying. So first, git clone the repo, and then we're going to run the install script, and then we're going to build it using Go. And then we're going to now confirm that Unifying was properly installed by running /unifying info. And then to flash the receiver is pretty simple. Just grab the firmware file off of GitHub. Logitech is very kind. They put all of their firmware files on GitHub. You could just grab it and flash it. The reason I chose the Unifying receiver CU12, I think, is that it supports Lightspeed, which is the faster and encrypted version of the communication protocol for Logitech devices. Next, we want to flash the dongle with the correct software. Firmware. So we're just going to run /unifying flash tacf and then the firmware file that you just grabbed from the Logitech GitHub. Just make sure that you're grabbing the correct firmware file that's supported by your receiver. And then finally, we can confirm that the dongle is flashed properly by running /unifying info, and it should show you that the file that it was flashed with. So some points of failure for me when I was running this using WSL, no matter what I did to attach and reattach the USB device and show that, it was recognized by WSL, it just would not work. So I would say that you should stick to a Linux VM because that's a tried and true environment. Next, we're going to have to flash and prepare our RF dongle. So this is the sender, and this is what we're going to be interacting with using PuTTY. So with your dongle, you just want to hold, or at least for my dongle to flash it, there's a little black button that you could hold while you're plugging it into your computer. So just whatever dongle that you decided to go with, just make sure you're following their instructions appropriately. Next, you want to flash it with the correct Logitacker firmware. So this can be found in the Logitacker repo. And just make sure you're flashing it with the firmware that is supported by your dongle. Logitacker very kindly in the README lists all the different types of dongles that it is compatible with, and it will just point you to that in their repo, and then also the correct baud rate for your PuTTY session. So that's pretty nice. And then now you can open up PuTTY, make sure all of your configurations are correct. For mine, the screenshot shows the baud rate, and yeah, and then just hit open and your interface or your terminal should pop up. And then just hit return a couple times on your keyboard. You should see that you're connected to Logitacker, hopefully. If this doesn't work, just double check your baud rate, double check that you flashed it with the correct firmware. It should work. Finally, we can pair the two devices, making sure they can communicate properly. So before we get into that, let's talk a little bit more about pairing. So the way pairing works for Logitech devices especially is that it, when it's put into pairing mode, it listens on a global receiving address, which is what you see on the screen right now. And it just listens for requests for about 30 seconds to a minute. And if anything else hits that global pairing address, then it would initiate the pairing sequence. Otherwise, it just kind of exits out. This is typically done with the Logitech Unifying software, so you could pair it. But we're going to be using Unifying because, we want to manipulate it to pair with our device. It's not actually a Logitech device. So with Logitacker open, we want to set our work mode to Lightspeed. And depending on what you flashed your receiver with and what it's compatible with, this could change from Lightspeed to anything else. But like I mentioned earlier, I chose Lightspeed because 1, it's encrypted, and 2, it's faster. So it's also the latest version. So I would recommend that. Then you want to put your dongle into pairing mode by running pair device run. And then now it's just going to keep making requests to the global pairing address. And then now with Unifying open on our VM, we want to run /unifying unpair all first to start with a clean slate, and then run Unifying pair so to initiate the pairing sequence. This step is pretty finicky. You could try to reconnect and disconnect your dongle, both dongles, a couple times, retry it. Eventually, it's going to work. And now with the devices finally paired, we want to run devices storage save and then tab to complete the address. We want to do this so that we don't have to go through this painful pairing process every single time we want to use the cable. With the stored, it's pretty convenient for the future. Now we can get into the making the cable portion. So this involves disassembling the cable and the dongle, and then soldering and reassembling the cable. So first, disassembling the cable. For this, I used an X-Acto knife. I just scored the chassis, the plastic chassis of the USB header. And then with a lot of force, I just kind of ripped it off. It was a very painful process, especially because the cable manufacturer decided to coat the inside of the cable, the header with some silicone. So that was really difficult to get off. This is a pretty painful step. Then we want to expose the pins so that we can actually, solder it onto the PCB. So for this, I just used some nail clippers. I peeled back the pins and then just clipped off the plastic. This worked like a charm. As you can see, all the pins are now exposed. And then we want to disassemble the unifying receiver, which actually ended up being even more painful than disassembling the USB cable. So I just, again, with my trusty X-Acto knife, I scored the chassis, and then eventually it became more of a brute force, like prying and snipping and stuff. But eventually, you can dislodge the PCB from the chassis. And then finally, to solder and reassemble, we want to make sure we have a good idea of the orientation of the components before we start. So I just took a picture of my cable, and then I also kind of took a picture of how I would want to, put the two parts together so that I have a reference later when I'm soldering. And then now you can really just snip off the wires. And then what I did was I just smothered every single component in a ton of flux. So flux, if you're not familiar with soldering, it's a substance that allows the solder or the metal to bond with other metal portions on the PCB, and this helps immensely. So then the way I soldered the header onto the PCB is just like holding up each pin onto the PCB and like heating it. And then, yeah, just soldering it together. It was quite a painful process. I ended up actually applying some solder to the pin on the PCB, and then also the pins on the USB header individually first. So they both were coated in a little bit of solder, and then I held the two components together when they were cooled and applied more heat on top so that they can fuse together. For soldering the wires, I stripped each wire, so that's just removing the plastic layer on top of the that kind of shields the internal like metal parts, and then I twisted the metal parts and I dipped them in flux, and then I put some solder on my soldering iron tip and then held it up to the wire, which had flux now, and so the metal kind of just transferred over to the wire and it coated it. And then after it was cooled, I held it up to each corresponding pin on the PCB, and then I applied more heat on top of that so that the wire itself would be soldered to the PCB. Tools I wish I had. I did not have any sort of like soldering clamps or anything to hold down my cables or my components, so it, stuff was moving everywhere. It was a pain. I ended up using some double-sided tape to hold it down onto my desk, which actually worked really well. But I would recommend, making sure you had everything you needed, a proper soldering setup before you attempt this project, because it can get pretty messy. Finally, payload development. I can't unfortunately get too deep into how we do this because I'm not supposed to promote any negative uses of this. This is all just for learning. So here we can go over like the syntax to write a quick script. So first we want a script clear to just start with a clean slate, and then script string, which inputs string. So we chose who am I, the classic. Script delay 500, that's 500 milliseconds to make sure it doesn't hit enter immediately after who am I, just in case it hasn't finished typing who am I out yet. And then script press enter, that just hits enter on your keyboard, and then script store, who am I. So we just stored it under the name who am I onto the device. Now with our script written, we can actually initiate the pairing process again. This is assuming, you're trying to use it on a target, right? So we want to load our device address from earlier when we stored it. So run devices storage load, and then you can tab to complete the address of your malicious USB cable. And then you can run pair device run to repair it. And then you can run inject target and then tab to complete the address. That's just going to set the address to your stored device. Script load, the name of the script. So in this case, who am I, right? So that's just loading that script onto the device. And then inject execute just runs our script. And so you can see here a screenshot of it running on my Kali. Who am I root? Amazing. Malicious use case is this. I made a phishing site kind of thing, credential harvester. You can see after inject execute, it opens it up. And the idea is, someone would walk away from their computer. They have this plugged in, so I can, run my inject execute. They come back, they're like, oh no, my laptop locked itself, and then log in, and I would be able to collect their credentials. So yeah, this is some more things to be putting onto my device, at least for me, for my future. I already have the credential harvesting stuff. And then it would be helpful if we can find some way to establish persistence on each of the different devices that we're targeting, and then how to be more stealthy. So just making a better cable that's not obviously tampered with, or making, better payloads. Now we want to finally talk about how we could protect ourselves against this kind of attack. But before we talk about that, let's consider, we want to consider that it can be scalable, especially when you want to deploy it across like a company-wide network or, across the school. We want to make sure that these solutions are scalable. And then number two, we want to make sure it still allows the functionality of, unmalicious devices like this mouse right here. So ideally, mitigation would meet those two criteria. On the operating system level, here are some mitigations that we have. For Windows, there's a security policy that allows you to specify what kind of devices are allowed to be run on your computer. Essentially, it's a whitelist of USB devices that you can allow. So this could get pretty granular, going all the way down to the interface ID of your device. So if you know exactly what USB devices you're going to be needing, you can just whitelist them as you use them. A similar thing could be done in Linux. You can either edit your rules.d files, or you can use a software called USB Guard. These are both pretty scalable across the network as well. For Mac OS, it's actually a unique case where Mac is actually more secure in this sense, because USB devices are automatically run in restricted mode. So when it detects an interface device, it will actually prompt the user to acknowledge that it's an interface device or an input device, right? And then for keyboards, it even tells you like, oh, can you press the function key next to shift or whatever. So it actually helps the user be aware that, oh, this isn't just a normal charging cable. This is, some sort of device that can inject keystrokes, right? And then finally, for, awareness and prevention, for awareness, we can have some like test campaigns. This is speaking like for example, a company. You can roll out some malicious USB cables, see if your employees fall for it, right? Have infographics that warn against this kind of attack, so people are more conscious of the kind of USB cables that they plug into their devices. And then also demonstrations like this one could help a lot, because it shows people how quickly they can get compromised by an attack like this. For prevention, we could use data blockers, which are physical devices that plug in between your USB device and your computer. So that basically just like renders any data transfer from the cable useless. It only allows power delivery. However, this would render your USB devices useless. So it's not really the best solution. Across a company, you could also implement a bring your own device policy, so that you like a no bring your own device policy, sorry, so that only company issued cables, devices, and everything could be used. And so hopefully that um, mitigates the risk of like an attacker, putting some like random USB cable outside in your parking lot and someone bringing that into your environment and using it, or just people bringing their own compromised cables into the work environment. Finally, physical security, making sure you have a good understanding of who has access to your physical environment or your physical like office or school, for example, or classroom, because, for this attack to work, the attacker has to be within, 10 feet for the signal to go through and for them to successfully like exploit this. So if you just don't have like random strangers or people with malicious intent within your proximity, that should be the best way to mitigate against this kind of attack. But yeah, thank you so much for listening to my demo. Let me know if you have any questions. You could reach out or put it in the chat, or if there's no chat, you could reach out to Swift. And yeah, thank you.